Hello, thank you for joining today. This presentation is Transform Your Risk Systems for Greater Agility with Accenture and AWS. Thank you everyone for joining today. This presentation is about how financial services organizations are transforming their risk platforms on AWS with Accenture. I'm Peter Williams, and I lead the technology efforts for AWS Financial Services Partners. At AWS, we're often asked how financial services organizations are using the cloud, and frequently we're asked how they're approaching transformation of their risk platforms in the cloud. I hope today you will learn how the scalability of the cloud is enabling risk systems to be much more flexible, and how Accenture's unique combination of financial risk domain knowledge and AWS technology expertise can really help. I'm very pleased to be joined by Graham Hughes of Accenture.
Thanks, Peter, for the introduction, and hello to everyone. Yes, I'm Graham Hughes from Accenture Financial Services. I'm very pleased to be here with you today. We've been working closely with AWS and FS organizations to help identify opportunities and migrate applications to AWS. We're going to run through some of the use cases and reference architectures today for migrating risk calculation workloads onto AWS. So onto the agenda. So first of all, I'll hand over to Peter to go through Amazon's GRC solutions, and then to give some context of grid computing within financial services today. He'll then discuss the challenges of managing grid utilization, and then he'll hand over to me to go through the Accenture grid solution reference architectures and some concrete examples, and then we'll have an opportunity to go through questions and answers or any other interactive discussions at the end of the call. Okay, over to you, Peter.
Thanks, Graham. We're first going to take a brief look at AWS governance, risk, and compliance solutions before delving into the financial risk grid solution from Accenture. The financial services move to the cloud is accelerating faster than ever. Organizations want to transform their business to be much more agile and responsive to customer needs. The primary reason customers cite for moving to the cloud is really agility, the ability to try new ideas quickly and often without large upfront investment of money and time. The cloud enables them to not only spin up servers when needed, but also to use services to do what we call the undifferentiated heavy lifting. So companies can use services for things like redundancy and encryption, and spend their energy and focus on features that really differentiate their business, features that really make them competitive. And that, to me, that's really transformational. AWS offers many solutions to help financial services address GRC needs across bank fraud detection, know your customer compliance, security compliance, and many, many more. All of them are specifically targeted to address business problems unique to the financial industry and help customers gain agility, reduce costs, and get to market faster. So what workloads are they moving to the cloud? Some of the first workloads are risk grid, since they're heavily dependent on the ability to burst compute at times of peak demand, and they benefit directly from the pay-as-you-go model of the cloud. It's worth taking a step back and examining the cloud journey that many financial firms have traveled over the past couple of years. Security has been a major focus for all organizations as they've considered the cloud, and this is especially true for financial services. As banks and insurers have learned about AWS security, many have determined that AWS's scale enables a level of investment in security that exceeds what their firm can invest in their own private data centers. In fact, is more secure. Security is managed in a shared security model, where AWS manages the physical security of the data centers, the hypervisor layer, and its AWS services, while the customer manages the security of their application and configuration. Compliance was really the other major area of focus in this cloud journey. Banks and insurance companies wanted to be sure that the AWS platform was compliant with standards such as SOC 1, 2, and 3, ISO 27001, 17, and 18, and PCI DSS, among many others. As you can see here, our security strategy stretches across three pillars: visibility, control, and auditability. AWS services are compliant with numerous regulatory requirements from regulatory agencies literally around the globe. So why are financial institutions investing in risk grids? The ability to use tens or hundreds of thousands of cores on CPU or GPU hardware on a pay-as-you-go basis provides unprecedented flexibility to meet risk and trading demands. Regulatory changes such as the Basel Fundamental Review of the Trading Book, or FRTB, are changing the nature of how risk is calculated and how frequently. It's a really interesting use case, and a lot of customers are talking to us about it in the context of one of their key workloads because of this regulation. FRTB is expected to result in a tenfold increase in regulatory risk calculations. And perhaps more importantly, for large financial firms, it will allow the incorporation of trading desk risk models where approved, but with daily backtesting rules to ensure it's consistent with market observations. This means that the risk models used on an intraday basis by trading desks is converging with those used for regulatory purposes and will increase the need for near real-time risk calculations rather than batch. This increase in calculation demand puts a lot of pressure on compute resources and the need to use the cloud. And this is one of the things that our customers are so excited about when they think about AWS. Graham, what types of risk drivers are you seeing among your financial services clients?
Sure, Peter. So some key trends in the industry tend to be data quality management as a challenge and a top priority to resolve. Regulatory scrutiny is at an all-time high. The cost base of technology continues to grow. Data volumes are growing. As you say, there are more calculations to run and reports to generate. Business insight is often deprioritized at the expense of remaining regulatory compliant. The risk stacks in particular have generally been siloed between market risk, credit risk, liquidity risk, as well as between the front and back office functions. And finally, legacy technology is a key constraint which generally affects cost and time for change in an organization.
Thanks, Graham. Traditional data centers are often proving inadequate in the context of, the large upfront investment requirements, as well as capacity limits and hardware that's difficult to keep up to date. When you think about some of these risk changes, and of course regulations have really evolved quite significantly over the past decade, you think about that progression and the benefits of having the ability to scale up and down kind of on demand, you can see why customers are getting excited about it. So let's look at the challenge of managing grid utilization. Staying ahead of demand for compute and storage capacity is challenging, and in a traditional data center, productivity and time to market can really be impacted while additional capacity is acquired. As you can see here, over time, the demand is increasing and reaching the limitations of what was provisioned, and it takes time to address that. The conflicting goals among risk users who really want the fastest calculation times and infrastructure teams who often need to maximize utilization can lead to delayed workloads and unpredictable completion times. This can lead to frustrated users who run fewer risk jobs, and ultimately the cost is reduced innovation. And to me, that's a worst case scenario. When you stop innovating, that's really when your business runs into trouble. The cloud solves these challenges by providing a variety of compute and storage types to meet many types of customer requirements on an on-demand basis. And the built-in features such as automated cluster management, replication, and encryption of data, and rest enables organizations to be much more efficient. Amazon EC2 enables you to increase or decrease capacity within minutes rather than hours or days. You can commission one, hundreds, or even thousands of server instances simultaneously. And of course, because all of this is controlled via web service APIs, your application can automatically scale itself up or down depending on its needs. Some people ask about our data center footprint and where do we have regions. And it's actually it's global. We span 5 continents. We have highly redundant clusters of data centers in each region, which a lot of financial services customers are excited about because, of course, they're global and they need that kind of global reach and ability to meet their customers in their own regions. Our footprint is continuously expanding as we increase capacity and redundancy and continue to add locations to meet the needs of our customers. The last thing I'll note on EC2 benefits is it offers many different instance types. We have customers that want to run CPUs for all certain types of calculations, and if they're running Monte Carlo calculations, they use GPUs. Some customers are using FPGAs, and we're excited to offer all of those and the ability to choose what you need for your particular needs. Now, Graham is going to walk you through Accenture's approach to cloud risk grid solutions. And I just want to add that, I'm really excited about the combination with Accenture, because I think it's one thing for AWS to provide the tools and kind of infrastructure and service capabilities, but it's another thing for a company like Accenture to come in, have expertise in how to use those tools, and in the same company have the expertise around the domain knowledge and how, for example, to address FRTB. This is a company that large banks are going to find out how can they address these major regulatory changes. So, Graham, I'll turn it over to you.
Thanks, Peter, for the handover and the introduction. Today we're focusing on an investment bank as an example, but I think the concept can equally be used in retail and corporate banking, and also in insurance for those workloads that are computationally heavy and may benefit from access to some degree of flexible resources. And within a typical investment or wholesale bank, there are a number of opportunities that can take advantage of cloud attributes, in particular pricing and risk calculations, data services and analytics, trade and transaction processing, as well as function-based software as a service or specialist application migration to cloud. And we've highlighted trading as well as the financial risk management functions here in the investment bank model on screen, as that's where we think most financial services institutions have either started migrating applications to private or, in some cases, public cloud, or are thinking about it, or hopefully will be after this call today. And so moving on to our approach, we very much propose a phased approach to adopting risk calculations on cloud. Each organization will generally have its own bespoke journey based on a range of business and technology factors, and so maybe at any point in this maturity model. Financial risk management, that's to say market, credit, liquidity risk, as well as front office trading risk, is a perfect place to start, as they typically have some form of HPC grid today, and we see this as converging with big data and analytics technologies in the very near future. So from the starting point of level 0, where you're fully on-premise today, and we see the adoption model has 3 stages for your cloud journey. And the first of these, level 1, is we're calling hybrid cloud. This is where you essentially extend your on-premise grid solution onto AWS. So you can realize short-term benefits with potentially minimal re-engineering of your existing grid framework or calculations, and whilst also benefiting from the secure and scalable capacity offered by Amazon. Level 2 is risk on cloud, and this is where we believe it's possible to migrate a majority of the end-to-end business process associated with risk calculations onto the cloud. And then finally, level 3 is a full migration. In essence, it's really the same as a level 2 architecture, but where you start to add more value-added features such as intelligent automation or machine learning, and using advanced analytics to make faster, more informed business decisions from all this data that you now have access to. Peter, does this resonate with the customers that you have at Amazon on their stages to cloud?
It really does. Companies, as they're looking to move to the cloud, really do progress in this way. That initially they want to take the opportunity to get experience with the cloud, to test the waters, and typically they'll extend their data center onto AWS and just use it as an extension of their data center. And very often it's sort of a very similar application architecture, in some cases just a lift and shift approach to the migration, just to get the experience and understand what their options are. And then beyond that, they advance and they want to optimize their architecture to take advantage of the native scalability that you can achieve.
Okay, thank you. So we're going to take a dive into the reference architectures for each of these models. and then an example. So for the first level of migration, this is a cloud-friendly extension into AWS. In essence, this model provides you with access to network, compute cores, be it CPU or GPU, as you've mentioned, memory, and temporary storage. The benefits of doing this we've covered before, but in summary are increased speed to market for creating new calculations, a shorter time to value for benefit realization, and finally, it enables innovation. So for example, if you don't have GPUs today and you want to trial them, it's a good way to test those out without having to procure new hardware. And you can test out new hardware or architecture configurations on a try before you buy basis, so you can iterate very, very quickly. In terms of the key features of the architecture, this is something that we recommend you can do by moving existing calculation workloads onto AWS. So you can continue to use an existing on-premise scheduler that manages your on-premise grid, and the model supports both synchronous and asynchronous interaction models. So for a typical risk calculation process running through the architecture from a process flow perspective, we have numbers 1 and 2 in the schematic here showing market data sources, as well as then trade, position, sensitivity, P&L, and risk model data from your on-premise systems. We then use AWS for grid compute, and would stream the front office data to the grid via any number of mechanisms, be it either file-based or message-based interfaces is something that is typical. In this view, we also show AWS S3 as an optional storage staging area for the data, which can be used in a batch processing model. And for real-time risk calculations, data can be streamed directly over TCP/IP from source to destination nodes. And number 4, based on either time or an event, such as a trade event, the scheduler can then start telling the grid to start performing calculations. There commonly be a number of base instances where the code is already deployed, and it's a matter of just streaming the input data to these nodes to perform their calculations. It is also worth bearing in mind that it's possible to start new instances and scale up, but note that doing this in line with any of your calculations would typically have some form of latency impact for startup, so it is worth thinking about front-running the scaling that you need to perform in this model. Then once calculations have been completed, results can then be returned, either streamed back or results made available for an asynchronous push or pull using any of S3 or Amazon EFS or a persistent data store even. Number 7 then shows the calculation results being returned to the calling mechanism, which in turn would generally persist these to a results data store that I'm sure you've all got today. These are typically also persisted to a warehouse or a business intelligence cube for reporting and analytic processes for end users and the risk functions. You could of course use AWS for hosting the analytic services too, so that would be another optimization. Then finally, for number 9, we also do recommend automation in this reference architecture through use of a CI/CD automation pipeline. This is mandatory really if you want to scale up and down nodes in the grid in an automated fashion and not have to invoke manual deployment techniques, which can be quite clunky. So in summary, this is generally similar to how things work in an on-premise risk calculation pattern that you'd see today. Peter, I think you've got a few questions.
Yeah, this is really helpful to take us through this. You mentioned security, and obviously that's a very important factor for financial services customers. How do you enforce security in this architecture?
Thank you. A very good and topical question, Peter. For risk calculations, we see that a common model is to enforce security in a number of ways. Almost all of Amazon's FS customers would make use of dedicated connectivity from a network perspective over Direct Connect. We can then also govern access rights to the environment via identity and access management and security group policies as well. And for the data itself, data transfer would either be secured via SSL or HTTPS if you were actually using that protocol as well for moving any of your data in and out. And then finally, data storage, we would recommend data at rest encryption, be it on your EBS volumes on EC2, as well as encrypting your S3 buckets, or for that matter, any other temporary or persistent storage platform that you decided to use as well.
Well, when you mentioned encryption, how are the keys typically managed in terms of encryption and decryption? What do your customers typically want to see there?
So for for this hybrid model, I think it's common for us to see a bring your own key onto Amazon's key management service. However, you can take that a stage further and make use of Amazon HSM key generation services if required as well.
Okay. And how about in terms of things like performance and resilience? Can you talk a little bit more about those two factors?
Sure. I think the first thing, and the common one that people are interested in first, is just network access between your front office and your risk calculations. Fast dedicated access to the grid would have to be over direct connect for guaranteed bandwidth, be that in a combination of 1 gig or 10 gig circuits. And we also would recommend that you choose locations as close to your own data centers as you can, which is reasonably straightforward given Amazon's global footprint, not just in the US but across the world. And then from a resiliency perspective, using more than one availability zone and as well as more than one region for redundancy is a good practice pattern.
Great, thank you.
All right, so moving on then to levels 2 and 3. So these are essentially the same architecture as each other, in that you can move as much of an end-to-end process onto cloud as possible. But the more mature versions make use of the data to drive business enhancement. So what's different about this? Well, we see a lot of the key features that traditional HPC grids, which let's face it, have been around for a while, and those of a big data analytics architecture, they're starting to converge. The big data or Hadoop ecosystem is large and generally confusing, but a blend of these components can take away a lot of the bespoke engineering requirements that you previously had to do yourself, and provide you with compute power segregated from but close to the data, and start to drive some real business change and value from that data. So what this architecture does it gives you a platform for intelligent automation, machine learning libraries, and artificial intelligence as well. And we'll discuss an implementation example in a few moments, but the key features of the abstract architecture include, so number one, recommending use of a Lambda data architecture, so that's not to be confused with AWS Lambda functions. So for both real-time and batch processing, different entry points into intraday and end-of-day calculation use cases. The second point is around calculations would be triggered by events, and the scheduler would live on cloud, and that would take care of scaling up and down the instances, so you wouldn't have to manually do that. Thirdly, we recommend the abstraction of your processors from IaaS and decoupling the two. And then fourthly, we incorporate a common data layer. This is for fast read-write of data and sharing of results between the different calculation execution nodes, especially important for those recursive calculations, as well as MapReduce style calculations that you have as well in the market risk space. And finally, we also show a plugin here for data analytics. And that means that just having real-time BI and data warehousing capability directly on the cloud is an important optimization, both from the latency perspective of having access to that data and being able to make informed decisions quickly. Then moving on to an example or a concrete example of what we see as a mature risk calculation on cloud model. And for each of these tiers, we have, for the inputs, we've got Kafka, which we're using for streaming, which provides both cross-AZ and cross-region resilient streaming for real-time and batch inputs, so it supports both models, be it messaging or files. For processing tier, we recommend the use of Spark as a process to distribute data between execution and worker nodes, and also to host the calculation logic, which could be on any number of languages. You could make use of your calculations that you've got today in an object-oriented language, or you may want to move them on to Scala, if that would be possible for even higher performance from Spark performance optimization perspective. For the data tier, we've been using Apache Ignite, which is an in-memory distributed data fabric, which is co-located with a Spark cluster, and hence all the data reads and writes are in the same memory space to the worker nodes. Underneath this, we also asynchronously persist the data to S3, but you could equally use HDFS or other storage mechanisms as well. We also have been using Yarn as a resource scheduler for the Spark cluster, and we use Zookeeper in order to monitor health of the Yarn manager too. So we've got fully fault-tolerant processes in place here. And then finally, for the analytics tier, very simply, we've been using Apache Zeppelin, which allows you to both use the data in the Ignite and Spark tier directly, which gives you very fast, dynamic data analytics. But it's true to say you could plug in any number of other tools here, and the list is really huge.
Yeah, that's Graham, that's very interesting. I love the way you walked us through this architecture and the fact that particular combination of Ignite and Spark streaming. One thing I wanted to add is that the use of AWS EMR service really offers the advantage of the fact that you can run your Spark nodes in a managed service mode. So it manages a cluster for you, but it can store data in S3, HDFS, Redshift, or many other different types of storage. So you've got a segregation of compute and storage that is actually quite powerful. And running Spark as a cluster means that your management overhead is greatly reduced. For me, the biggest advantage, though, is not just the architecture itself, but the fact that given the automation that's baked in from deployment through operations, it enables your development teams to focus on the real business differentiators, as we were talking about before, and to get away from the plumbing. What we're seeing is that companies that are embracing the cloud, and we're seeing this more and more in financial services, as they move into the cloud, they're recognizing that their development teams can be so much more efficient, not only because they're focused on these differentiators I mentioned, but also utilizing tools such as continuous integration, continuous development, and capabilities that enable you to manage your infrastructure as code. Literally, we're all accustomed to managing your source code and version controlling that. But what's amazing to many customers as they move into the cloud is that, in fact, you can use version control for your infrastructure. So everything that is running, everything that you see here that Graham has taken us through, whether that's running across multiple availability zones, even multiple regions, all of that capability is something that is scripted, and therefore you can version control it. So when teams then move towards what we call DevOps approach, which is really the kind of integration of development teams and IT operations working collaboratively to manage their entire deployment process, what you end up with is a development team that is highly effective and agile and able to make changes at a very rapid pace and really increase the velocity.
And that's a really important point, Peter. And what I think we at Accenture are more commonly asked by everyone is, what is the business case associated with moving to cloud? And obviously, it's very easy to talk about any cost savings that can be associated with the use of elastic computer resources rather than planning for peak capacity. However, I think it's true to say that cost save is interesting, but very much where the real value comes is from freeing up your development resource time on either waiting for infrastructure to be delivered, or for spending their time deploying code and upgrading test environments, for example, which let's be honest, add relatively little value. So what this does is it may not reduce cost, but gives you back productivity improvements in terms of actual value creation to the business, and that's something that we think is the biggest future benefit of an architecture like this. However, we realize that there may be some business case hoops you need to convince your CFOs, CIOs, CEOs, whoever it may be, that this is the right path to follow. But we think that by taking this phased approach to migration and focusing on what you've got today, moving it out first, you can start to realize some of those benefits from a cost save perspective and plug that back into your innovation cycle. And I also believe that a lot of the applications that you've got today, which are maybe sitting on large relational databases, are starting to creak at the seams. We see that convergence of big data technologies, and again, what I'm showing here is almost a big data architecture, and data processing and grid compute were very much thought of as separate architectures maybe only 3-4 years ago, but now the tools that are available, such as Spark, give you the ability to not have to do the underlying work, and it does a lot of the scaling and distribution of both the data and the underlying calculations as well. So it's a highly valuable architecture.
You know, as you're talking, Graham, one of the things that occurred to me is kind of the, you mentioned, you touched on sort of the business case, and sort of having to help other business stakeholders within your company to understand why an investment in something like continuous integration and continuous deployment approach is worthwhile. It makes me also think about kind of tying back to one of the benefits of, I think, working with Accenture, which is that Accenture really, I think, is and what we've seen is does a great job with helping our customers to navigate this journey. It takes a number of different disciplines. People look at AWS and they're like, wow, 90 services, that's a lot of services. How am I going to learn those services? Well, you don't start off by learning all 90 services, right? You work with a company like Accenture that can help you plan not just an architecture like this that helps you specifically meet your risk grid needs, but very often, and Graham, I'd be interested in your thoughts about this, I believe very often it leads to other kind of more business case conversations within a company, and how they approach the cloud in general, how they coordinate and really transform the way they operate to take advantage of the cloud to make the right business case, sometimes to executive levels, and to bring the required parties from infrastructure development, business, and executive teams together on a common vision. And I don't know, how much of that, resonates with you, Graham, in terms of your experience.
So I think, for any new business requirements, again, leveraging the power of AWS is absolutely a value add, both from having access to infrastructure as well as using any of the services, as you mentioned. I also think that within financial services, almost all new projects that we have are based on data analytics to some degree. And what that means is it's then, the old technology stacks that you had are no longer fit for purpose, and business are demanding more from that data that exists there. A lot of on-premise data lake solutions have been built up over the last few years. I think it's fair to say adoption has probably not been as great as it could be. Again, just due to the time to get it installed and up and running, having the ability to run essentially the same architecture on cloud gives you the ability to fail fast that never really existed before from a financial services business perspective. So very much mirroring the way that the technology startup industries have evolved. And certainly some of the valuable cases we see is working with businesses to identify new opportunities to create revenue, which is a real business case. Revenue generation techniques is where they see the value of using cloud technology to compete with the fintechs of those worlds.
So at this point, I wonder if we should take questions from the chat and the users that may be coming through. Chris?
Yeah, I've only got a couple of questions so far, so if others could just put some questions in whilst we speak, that'd be fantastic. So I've got a question here about, will the EC2 instances be able to scale up as much as required? Is it possible, for instance, in all regions to scale up to, say, 100,000 cores? And then related to that, is there a general sort of recommendation on your CPU to GPU mix?
I think so. Absolutely, we have customers today that are using hundreds of thousands of cores in multiple regions, and that's one of the really compelling things about the architecture. And we weren't in this webinar able to go into the lower level behind the depth of what Graham took us through. Behind there is actually a messaging infrastructure that I think you alluded to, Graham, using Kafka, which actually enables a cross-region calculation grid, which can be very, very powerful depending on what the customer's needs are. So I'm pretty excited about that and the ability to run a global grid. Really exciting, and I want to get Graham's views on that. The other thing, just to touch on that point about GPU versus CPU, it's all about your workload. Typically, what I see is that for Monte Carlo simulations, where you're running the same calculation with different inputs in parallel, GPU is the most performant by far, by a long shot. And a lot of our customers are using our P2 instances, the NVIDIA K80s, which are just incredible. And then for other types of calculations that are not so parallel, they'll tend to use CPU. So I think it just depends really on your use case.
So yeah, thanks, Peter, and thanks, Chris. I think the question does depend on what degree of engineering you're able to do, and to decouple the EC2 instance type from the architecture, and that's really the beauty of us recommending using Spark, because you're now no longer dependent on specific combinations of cores or memory on a machine, and you let Spark take care of that for you. And so that's really the value add of using Spark. Spark is memory, does use a lot of memory, and that's really the advantage of doing so. A key trend in technology tends to be that your memory is relatively cheap, but it should be used wisely at the same point in time. So yes, it can absolutely scale, and as you mentioned, within this domain, risk grids tend to be in the order of potentially a couple of 100,000 cores is a common configuration if you look at what a large global institution has. And we've seen instances, I think even presented at reInvent last year, around some of the AWS customers that are using risk grids in the order of 200,000 cores. And the other thing to note from an optimization perspective, where you've got real-time risk calculations and they're time critical, you may have a combination of on-demand and reserved instances. But again, as you can start to evolve those for less critical workloads to spot instances in any region, then you can start to take advantage of the cost optimizations that come with using the spot market as well. And that's really a mature end state that can deliver significant value from a financial engineering perspective back into a financial services organization.
Yeah, and that ability to manage the spot instances for you within our Amazon EMR service is another great example where you're able to really optimize for cost and performance in a way that doesn't cost your developers any time. It's literally a configuration. So it's extremely powerful, and something that a lot of our customers are pretty excited about.
Exactly. And to talk about the combination of CPU and GPU, again, it comes down to how you've written your calculations and how well suited they are for GPU, which generally has less memory utilization but need to be much more in line. So it depends on the dependency. So where you've got recursive dependencies for your market risk, and for example for FRTB, then you may find that CPU is a better model. But again, as Peter said, it depends on the workload. And again, the beauty of Spark is it supports both CPU and GPU operation too.
Chris, I'm seeing a couple of questions here as well, but what do you have? What others do you have?
Yes, a few more questions. So can this architecture be run in a self-contained environment in terms of, does it need internet access, or can you use a dedicated network into AWS?
I will take that one. Yeah. So again, a good question, and very, very topical for some people who may be on the call. So you've got a combination of choices here. You can run this in a standalone mode, i.e. with no dependencies on the outside internet. So yes, you can absolutely run this setup using your own installation, your own operating system, and your own binaries and third-party binaries deployed on top as well. So yes, it can be run in a fully standalone mode. Any others, Chris?
Great. Yes, sure. Also, we've got a question here. How have you been able to convince management to adopt this architecture? So I think this is around the full sort of journey to cloud and getting the appropriate sort of compliance and management approvals to do so.
Yeah, good question. And that's probably from an Accenture perspective where the majority of our work has been in financial services over the last 2 years. I don't think there's a one-size-fits-all answer to that either. Every organization, especially how it's configured from a global perspective, really, who are those key regulators, who are its key customers, which business lines are they in, and how they're set up from a global and regional and departmental perspective have a big impact on that. So, depending on the regulator's appetite to embrace cloud and work with financial institutions, then it's a very different approach. And we've seen a lot of instances where there are no commonality between regulators right now on how they want to approach it. But what I will say is that there's a baseline level of regulation that you need to have to ensure that your environment can be audited. And the beauty of Amazon is that it's typically got higher levels of control and auditability than any of the on-premise data centers have today. So all boxes are checked there. And I think that's the first thing that starts to convince the CISOs of this world that a risk architecture running on Amazon is as good, if not better, than what they're running today. Because again, as we talked about security, just the simple fact that you've got encrypted data both in transit and at rest is quite often a much higher level of security than you've got on-premise today. However, that not to say it's without risk. You still need to make sure that you've got security groups set up, VPCs and subnets configured in the correct way, and more and more scrutiny needs to be applied to that. So I think it's a very complex question, Chris, and we've seen instances of every financial institution focusing on it in a slightly different way. And it's been a learning journey for everyone, not just from a technology perspective, but regulators and even more so internal compliance officers are the ones that have had to learn most about cloud technology and its implications for the business. But I think it's true to say market forces are prevailing, and really it's a question of why would you not start to move some of these workloads to cloud whenever it gives you all of the benefits that we've just talked through.
One thing I would just touch on there, it's interesting, the security teams that have worked, and this goes back to the past 2-3 years, have worked to understand how they can be secure in the cloud. It really came full circle, where initially they were not sure how it would be possible, right? And then as they examined the capabilities, they recognized that they can do two things. One, they can monitor the environment in AWS at a level that is not typically possible in a data center. And I'll give you an example. All API calls to AWS services are monitored and logged in AWS CloudTrail. It's not optional, right? It's just built in. The ability to track, that means anytime somebody's logged in, anytime somebody scales up, anytime data is written to S3, it's every operation can literally be tracked. And one thing that's important about that is where in an on-premises data center, historically, it's very often been a matter of kind of working with development teams and asking them to hook into libraries to make sure that all calls are monitored, or using certain services that could capture certain pieces of the overall equation. Due to the nature of how the AWS cloud is designed, the logging and tracking is built in, and unless you go out of your way to turn it off, in some cases it's there anyway, you're going to see everything that happens. And I think that gave a lot of comfort to CISOs, because all of a sudden they realized that they were going to have full transparency into everything that occurred. which is really powerful. The other point on that is that the automation that is then possible, where you can automatically capture and track any violations of your preferred security configuration. We have a service called AWS Config, which you set up how you need your environment to be configured, and any discrepancies against that are monitored and alerted. So the automation around security is really an important factor, and I think security teams becoming more comfortable. And the same transformation occurred in compliance teams for similar reasons, the auditability and the automation, to where they feel like, wow, I actually have a lot more confidence in my compliance with the regulations that I'm accountable for.
Sounds good. I've got a couple more questions. So there's one around liking the look of the suggested architecture, but how might firms move this through sort of development test, performance test, and into production? You know, how might they want to set up these environments to prove it before they actually push it into production?
So I mean, that really is the beauty of having not just a CI/CD pipeline, but having infrastructure as code. It's very easy. In fact, it's as easy to spin up a very small environment for development and test as it is for something that can span many thousands of instances as well. So essentially, it's the same work that you need to do, and it's all about just scaling it for the environments that you need to perform. So going back to Peter's point, implementing automation at the beginning means that then it's very, very easy, not just to scale out, but also to test different combinations of instance types, etc. as well. So probably one downside of an architecture like this is you've got infinite combinations of things that you could do. So a performance test or non-functional test scenario is now open-ended, because you could go through any combination of options that you would want to play with from even from an IOPS perspective as well.
Thanks, Graham. One other question that's come in, and I think this is probably for you. What would you say is the biggest challenge that your clients face when they're moving to the cloud?
So I think the culture change is probably the first thing. Everyone starts out with a lot of fear of what public cloud actually is. I think once they then start to find out more about the flexibility and the services that Amazon provide, they become, again, very excited about it. We also quite commonly hear, if we had $1 every time we heard clients being afraid of having provider lock-in, we would be very rich. But again, what we've seen is that the value that you can get from going deep with some of these services mean that you can start to realize benefits, and ultimately that's what businesses care about. It's about being able to do things fast and deliver value. Obviously, you've got to remain regulatory compliant and you have a redundant architecture. So we think that you can mature to a multi-cloud model in the future if you want to. However, I think that business case comes down to making your business happy first and foremost. So I think that's the challenge, dealing with all of these combination of factors and getting the business comfortable with and generally they've got the biggest say, because they want things to be done quickly to help improve the top line, which in turn can help reduce the bottom line and make shareholders and employees ultimately more engaged and happy in their organization. Okay.
Thank you.
We got time for any more questions? I'm not sure.
Yeah, we've got a question here around, have we been able to prove the architecture at all? There's a number of technologies there. Some of them are fairly recent. Have we gone around sort of proving that they're fit for purpose? Yeah,
so good question. And really, this architecture here has been embryonic from some of the work that we've been doing in market risk at some of our clients. But there will be a session at the New York Loft event, AWS Loft event next week, where we'll give anyone that's interested an opportunity to walk through with some of our senior architecture team, who actually have got a pilot ready to show people how this can work. And generally, we work under NDA and the work we produce is client IP, so that's not something that we would ever show. However, we've got Accenture versions of these that we can give you a view of how you would roll this out. So yes, absolutely, we've got Kafka working with Spark, with calculators running on top, and plugged into an Ignite data fabric, and also using some of the BI tools and at the end to show you an example of what this architecture looks like. So we look forward to presenting that in the LOS next week. And again, we can arrange to do that with any of interested parties. After the event, we can set up one-to-one demos. And we'd also have an opportunity, I believe we've got a slot at reInvent later this year as well to go through it too. So yes, we would love the opportunity, or certainly the guys will that have built it, to go through this with as many people that are interested, as we believe this is the future of risk calculation. Okay, so I think that's all we've got time for, Chris. But if there are any questions, then please do email either Peter or myself in the first instance, and we can route you through to the right place to go to.
Well, just want to thank everyone for attending today's webinar, and thank Graham for being here with us. Thank you so much, and have a great day.
Thank you. Thanks, everyone.
Thanks.